On a storm-battered Scottish shore, the retreating tide reveals something that looks like a heap of wet, knotted string. Beachcombers wander closer, expecting torn kelp, or the rotting rope of a lost fishing net. Then a fold of the tangled contracts, glistening in the gray light, and they realize the thing is breathing. This is not rope, and it is not many creatures woven together. It is a single living animal, and no one standing on that beach could guess how far it would reach if it were ever drawn out straight. Uncoiled, this creature could outmeasure the largest animal that has ever lived. A blue whale stretches to around 30 meters and weighs as much as a fleet of trucks. One bootlace worm, recovered from a beach after a storm, was estimated at nearly 55 meters, and it weighed almost nothing at all. That would make this thin, dark ribbon the longest animal on Earth, longer than 3 London buses parked end to end, yet narrower than a shoelace along almost its entire impossible body. Yet somehow it lives its whole life without anyone noticing its scale, because it is almost never seen fully extended. But length is the least dangerous thing about it. Draw a finger along its body and it weeps a thick, pale mucus, and hidden inside that slime is a chemical weapon. In the laboratory, scientists have dripped this mucus onto cockroaches and watched them convulse and die within minutes. The longest animal in the world is also quietly, elegantly venomous. It is no threat to a person's life, but to anything the size of a beetle it is a death sentence. And it lives, almost entirely unnoticed, beneath the cold rocks of Europe's most crowded coastlines, a few meters from where people swim. The bootlace worm, known to science as Linnaeus longissimus, spends its life in hiding. It coils beneath boulders and threads itself through mud and seaweed along the North Sea, from the coasts of Britain to Norway, and is rarely seen unless a storm tears it from its shelter. For most of human history it was simply mistaken for debris, ignored as another strand of weed. Then, in 1864, a specimen washed ashore near St. Andrews in Scotland, and the naturalists who carefully unrolled it wrote down a figure that has unsettled biology ever since. They estimated its length at close to 55 meters. If that number is honest, this fragile worm outstrips the blue whale, the giant squid, and every long-necked dinosaur that ever lived. But a stretched-out worm is a slippery thing to trust, and that single Victorian measurement would spark a quiet scientific argument that has never entirely settled. How do you measure an animal that refuses to hold still, one that can nearly double its own length simply by relaxing its muscles? That question would wait a long time for an answer. What is not in doubt is that the strandings keep happening. Every so often, after a heavy blow of weather, long dark ribbons appear along northern European beaches, sometimes stretched across the sand like discarded cables. Most people walk straight past them. A few poke at them with a stick and move on. Almost none realize they are looking at a contender for the most extreme animal in the sea, and fewer still know what that mucus on their fingers can do. The ordinary and the extraordinary lie side by side on the same wet sand, and hardly anyone can tell them apart. Take the worm apart and there is almost nothing to it. Its body is a flattened brown ribbon, often no wider than a bootlace, colored deep chocolate to near black with a faint iridescent sheen where the light catches. It has no bones, no shell, no legs, and no face an untrained eye would recognize. What it does have is muscle, arranged in crossing layers that let it stretch and contract like living elastic. Because of that, its length is never truly fixed. It is always, in a sense, up for negotiation. That elasticity comes with a strange gift and a stranger cost. A bootlace worm is astonishingly delicate and will break into pieces at the slightest rough handling, snapping like overstretched dough. Yet many of those broken pieces do not die. Given time and calm water, a single severed section can regenerate into an entire new worm. It means one individual, shredded by a storm, can become several. The longest animal on Earth turns out to be one of the hardest to destroy simply by tearing it in two. To move, the worm glides on a carpet of its own mucus, rippling through crevices too tight for anything with a skeleton. It can knot itself into a dense ball for protection, then loosen and pour across the seabed like spilled ink. There is no rush in any of it. This is an animal built not for speed but for patience, for reaching into places nothing else can follow, and for waiting, with its weapon always loaded. In the tangled dark of a kelp holdfast, a single worm may stretch for many meters, threaded through the roots like a dark living vein. Then there is the slime itself. The entire worm is sheathed in a thick coat of mucus that it uses to glide, to breathe through its skin, and to defend itself from the mouths of larger animals. For centuries no one thought to ask what was actually in it. It was a question hiding in plain sight for well over 100 years. Then, in 2018, a team of researchers at Uppsala University in Sweden decided to find out. They isolated a family of previously unknown toxins from the worm and its slime, and gave the most potent of them a name, Nemertide alpha-1. To test how the toxin worked, they exposed cockroaches and crabs to it. The results were fast and merciless. The compound attacks the sodium channels that nerve cells rely on to fire their signals, jamming them open and throwing muscles into uncontrollable spasm before locking them into paralysis. Cockroaches given tiny doses convulsed and died within minutes. A shore crab caught in the mucus simply stopped working, its legs frozen mid-stride. The gentle-looking ribbon on the beach was carrying one of the ocean's more efficient nerve agents. What made the discovery matter beyond the beach was its precision. Toxins that target sodium channels so exactly are of intense interest to medicine, because those same channels govern pain, movement, and the steady rhythm of the human heart. A poison refined over hundreds of millions of years to switch a nervous system off is also, potentially, a blueprint. Researchers now catalog these nemertide compounds alongside the venoms of cone snails and scorpions, hunting for the ones precise enough to become drugs. The slime that kills a cockroach in minutes may one day teach chemists how to build something that heals. So what is a slow, boneless, near-blind worm doing with a weapon like that? The answer is hidden inside its own head. Like all ribbonworms, the bootlace worm carries a proboscis, a long muscular tube coiled under pressure inside its body. In a fraction of a second it can turn this tube inside out and fire it forward, far faster than the rest of the animal could ever move. It is, in effect, a living harpoon launched from a creature that otherwise barely seems to move at all. Coated in that toxic mucus, the proboscis lashes out at small crustaceans, marine worms, and anything soft enough to seize. The prey is stunned before it can flee, then drawn back and slowly swallowed. So the toxin is not only armor, it is ammunition. It lets an animal with no speed and no jaws successfully hunt creatures that are quick, alert, and armored in shell. The open question of what the slime is for has two answers at once. It is how the worm eats, and how it survives being eaten. That double purpose may explain why so little seems to prey on the worm in return. A fish or crab that bites into those dark ribbons gets a mouthful of nerve poison for its trouble, and predators learn such lessons quickly. Left mostly alone, the bootlace worm can simply keep growing, adding length year after year in the cold and the dark, until it becomes the tangled giant that a storm one day rips loose and throws, astonishingly, onto a public beach. By then it may have been growing, unseen, for years, and nobody truly knows how old the largest specimens are. Which carries us back, at last, to that impossible number. Modern biologists treat the 55-meter figure with real caution, and the reason is the worm's own elasticity. A relaxed bootlace worm can stretch to many times its resting length, thinning as it goes, until it is on the very edge of snapping. Measure the same animal while it is tense and it is comparatively short. Measure it stretched and it becomes a monster. Some biologists now argue we should describe its length as a range rather than a record, a band of numbers instead of a single boast. And that is the real twist buried in the story. We crown the blue whale as the largest animal by sheer mass, and the bootlace worm, uncertainly, as the longest by reach, but the worm quietly makes a mockery of the whole idea of a record. Its length is not a fixed fact about the world. It is a decision the animal makes, moment to moment, muscle by muscle, stretching and gathering itself as it pleases. The longest animal on Earth is only as long as it currently chooses to be. So the next time a storm empties the sea onto the sand, look twice at the tangle of dark string lying near the tittle-line. It may be the longest animal that has ever lived, resting quietly between two of its many possible lengths. For all our instruments and records, some animals refuse to be pinned to a single number, and this is the strangest of them. It asks nothing of you, and it warns you of nothing. It simply keeps its poison, and its true size, entirely to itself.